Welcome to lecture number 13 for ECE 320 Electronics 1, H-bridges. Now, what we've looked at before was a transistor switch. A switch can turn a device on or off. That could be a motor is either on or off, a speaker is at its neutral position, forward, back to neutral, only goes one way, an LED light turns on or off. That's all you can do with a single transistor. If you want to have something go forward and reverse, change direction, you need an H-bridge. Now an H-bridge looks like the following. Kind of looks like the letter H, hence the name H-bridge. Here I've actually got 4 transistors. I've got a friend, the NPN transistor going to ground. That's a switch. That can take this side and tie it to ground or leave it floating. In addition, I have a second, a PNP transistor on the same side. That can either take this point and leave it floating when the transistor is off or pull it high. So the idea is if I want to have current flow left to right, I turn on T1 and T4. Current flows left to right. To have current flow right to left, reverse, I turn on T3 and T2. So I can either have it go forward or reverse. There's also 2 other modes. If I turn on T2 and T4, that's active braking. That's like taking a motor and shorting the leads. If I do that, the motor kind of grinds to a halt. I convert the kinetic energy into heat as the motor is being operated as a generator. The 4th mode is turn everybody off. There the motor just coasts. The last mode is smoke. Turn all the transistors on. I just connected power to ground and the smoke gets out. You're not supposed to do that. Usually there's just 4 modes of operation. To illustrate that, here I've got an H-bridge. This is a little H-bridge that we're going to be talking about later in this class. It's off of eBay for $1.98 out of China. Actually a really nice H-bridge, capable of 3 amps. I've got 2 wires controlling it. That comes from microprocessor. The processor is a WIMP. It can't drive a DC motor, but using an H-bridge, I can drive the DC motor. Now with a transistor switch, I could turn the motor on or off. With an H-bridge, I can do more. Here I actually have 3 different modes. It's spinning clockwise, when applying plus 3.2 volts across it, counterclockwise, minus 3.2 volts, and off, 0 volts across it. So you actually have those 3 states. Forward, stop, reverse. That's what an H-bridge can do. And it's not just motors. If I have that drive a speaker, I can the speaker go up, neutral, down. Use both directions for the speaker. Or other devices, if you want to have more than just 2 directions, you need an H-bridge. So what we want to do with today's lecture is look at how is this circuit built? How does it work? So at the heart of an H-bridge are these 4 transistors. I've got 4 different modes. To have the transistor go forward, what I want to do is turn on transistor 1 and transistor 4. To do that, this is a PNP. PNPs are kind of backwards. To get current flow through the base, I need to ground the input. That turns on T1. To turn off T2, I ground this input. So I've got 0 volts on both sides. There's no current through the diode. T3 is off. Tie both these to 10 volts and there's no current. No current means it's off. And T4, apply 10 volts across it. Transistors are really current limiters. The current is going to be the minimum of beta IB, the current limited by the 8 ohm resistor, and beta IB over here. For this design, these are TLP transistors, the gain's 1000. The current over here is limited to 1.72 amps. The 8 ohm resistor limits the current to 1.025 amps. And this limits it to 1.43 amps. The smallest of the 3 is from the 8 ohm resistor. What that means is both these transistors are saturated. Beta IB is more than IC. And this becomes 0.9 volts, the saturation voltage for a TIP transistor, or 9.1 volts here. This becomes 0.9 volts, or 0.9 volts. And the voltage across the 8 ohm resistor is now 8.2 volts. And that's what this comes. The max current I can get is 8.2 volts over 8 ohms. To have the motor go in reverse, all I do is switch them. Instead of turning on T1 and T4, turn on T3 and T2. And here pretty much all the analysis stays the same. The current is limited by the 8 ohm resistor, so these 2 are saturated, and I get 9.1 volts on the right, 0.9 volts on the left. There's 2 other modes. If I want to do active braking, that's where I short the leads of a motor. If I do that, the motor becomes a generator. It converts the kinetic energy into electrical energy that gets burned up in the armature as I squared R losses. To turn on the bottom two, I set both these to 10 volts. That turns on the NPNs. Turn off the PNPs, so these are 10 volts. Make everybody 10 volts, and the transistor turns off, or I go into braking mode. The last case is coast. Turn off everybody. So the PNPs are turned off, apply 10 volts at the base. The NPNs are turned off, apply 0 volts at the base. Everybody's off, the motor's just spinning freely. Those are the 4 modes for an H-bridge. If you do it wrong, a transistor won't be saturated. Ideally, I want these to be on or off. They're switches. If I do it wrong, like make this base resistor too large, then the current is the minimum of the 3 currents. Again, transistors are current limiters. Transistor 1 limits the current to beta IB, 1.73 amps. The 8-ohm resistor limits the current to 1.025 amps, like before. This transistor T4 now limits the current to beta IB, 860 milliamps. If this transistor wins, is the current limiter, then this one goes into active mode. The current becomes 860 milliamps, and transistor T1 saturates. The voltages, since this one's saturated at 9.1 volts, the voltage of V2, I can't tell. It's somewhere between 0.9 and 10 volts. That's the active mode. To find V2, I have to back into it. If V1 is 9.1 volts, I know I times R. So I can back in and find out that V2 must be 2.22 volts. It's in the active region. That's actually bad. This transistor is going to get hot. It's dissipating the current, basically 2.22 volts times 8.6 milliamps. It's going to dissipate 2 watts. That's not supposed to happen. That comes from these resistors being too large. If you want to design an H-bridge, what I need to do is pick the base resistors so that beta IB is more than IC. In this case, if I have an 8-ohm resistor, say a speaker, I want to push 1 amp through the load. Make sure beta IB is bigger than 1 amp, or since beta is 1000, IB is more than 1 milliamp. Pick something bigger than 1 milliamp, like 2 milliamps. If I want this to be 2 milliamps when they're turned on, that just says that the resistor should be 4.3 kilo ohms. And it's the same calculations for all 4. You might as well make them all 4 the same, 4.3 kilo ohms. That's designing, building an H-bridge. H-bridges are kind of useful, so not surprisingly, you can buy ready-made H-bridges. For example, a TLE5205 is an H-bridge on a chip. It's actually half an H-bridge on a chip. That's $7 on DigiKey, and you've got 2 binary inputs, and that drives your output. Nice thing about this chip is the previous design, I'm kind of limited. If the power supply is 10 volts, to turn this off, A has to be 10 volts as well. What the TLE5205 does, it acts as a buffer. N1 and N2 can be TTL levels, 0 volts, 5 volts. The power supply can be anything up to 36 volts. And so a 5 volt input can turn on and off the 36 volt motor. So what's kind of nice about the TLE5205. 2 years ago, these appeared on eBay. An even better solution is order off eBay. A L298N is an H-bridge on a chip. It's $1.99 out of China. It varies by year. Let's see. What this one can do is you actually have 2 H-bridges, one on the right, one on the left. That's what I was using in the demonstration earlier. It's got a heatsink on it, your inputs and power. The limitations on this chip are the power has to be somewhere between 5 volts and 35 volts, so it's very versatile. It can drive up to 2 amps per channel, and you actually have 2 H-bridges on this chip. So apply your signals to input 1 and 2 to control the left side, input 3 and 4 to control the right side. Connect your motor, speaker, whatever you want to these pins, and I can now drive the motor forward and reverse, like I was showing over here. Or I can connect a speaker to it, or later on, you can connect a stepper motor to it when I need 2 H-bridges. Now, kind of a recommendation, if you want to demonstrate knowledge of H-bridges, build it at the transistor level. Again, using one of these boards doesn't really demonstrate much. On the other hand, if I want to demonstrate something else, like use of a microprocessor, use of stepper motors, building a senior design project, then definitely do use one of these chips. For $1.98, it's kind of hard to beat. Basically, if it takes you more than 5 minutes to build an H-bridge on your own, it's cheaper to use one of these boards. So that's kind of an H-bridge, similar to a transistor. A transistor can turn a device on and off. An H-bridge has more options. I can make it go forward, make it go backwards, I can go active braking, or let it coast. And that's lecture number 13, H-bridges, for ECE 320 Electronics 1.